Hey guys, so for today's video, we're going to be continuing, as always, our discussion of Ohm's law, but this time we're going to start solving problems. We're finally going to be doing the math for Ohm's law. So, Ohm's law by itself is really just a relationship between voltage, current, and resistance. And typically, the most basic bare bones formula of Ohm's law is voltage is equivalent to your current multiplied by your resistance. But you can transpose this to find other relationships between these variables. So, in order to find for current, it's just voltage divided by resistance. We've already seen this before. But if you want to solve for resistance, it's voltage divided by your current. And in this video, we're going to be solving a total of 9 problems, and we're going to have 3 problems for each equation. So, let's get to it. So, let's start with the problems that solve for current, or I. What is the current produced by a 12-volt battery attached through a wire whose resistance is of 2 ohms? So let's take a look at our given. We are being told that our voltage from the battery is 12, so we've got 12 volts, and our resistance is 2 ohms. By the way, ohms, or that omega symbol, is the unit for resistance. So, what's our solution? What formula do we use for this? Well, remember, we're using voltage and resistance in order to find current, right? So we gotta use this formula for I over here. So I is equivalent to V over R. We already have the values for V over R, and they're also in the correct units. So let's just plug them in. So our current is equivalent to 12 volts divided by 2 ohms. And if you put that in your calculator or just use your brain, you've got 6 amperes. So our answer is the current produced is worth 6 amperes. Now, for this problem, how many amperes are produced from a source of 36 volts running through a resistance of 1.5 times 10 to the power of 2 ohms? Don't be intimidated by the bigger numbers, it's really just the exact same thing. So again, with our given, we've got 36 volts, and resistance is 1.5 times 10 to the power of 2 ohms. So for our solution, of course, we use the same formula. 36 volts divided by our ohms, put that in your calculator and you get 0.24 ohms. So our answer should be, the current produced is 0.24 amperes. Now how about this problem? This problem is a little bit more realistic, and you might actually find yourself handling this problem before. So let's read. Imagine you have a portable speaker that runs on batteries. The speaker has a resistance of 8 ohms, that's ohms by the way, that omega symbol, and is powered by a battery of 12 volts. Calculate the current flowing through the speaker to ensure it operates within safe limits. So what's our given? We're being told first that our resistance is 8 ohms. So R is equivalent to 8 ohms. And we're also told that the voltage of our battery is 12 volts. So put it in our solution. 12 volts divided by 8 ohms is 1.5 amperes. So our answer is the current flowing through the speaker is worth 1.5 amperes. This time, let's solve for voltage. What amount of voltage is required for 9.5 amperes to pass through a resistance of 4.2 ohms? So what's our given? This time we're given current and resistance, and we're being asked to solve for voltage. So we're first being told that our current is 9.5 amperes. So I is equivalent to 9.5 amperes, and our resistance is 4.2 ohms. This time, what's our solution? Well, let's go back to our list of formulas. We are being asked to solve for voltage, right? And we're given current and resistance. So what formula here could possibly satisfy those requirements? Well, it's this one over here, right? We're solving for voltage, and we're using current and resistance. So, put that in your calculator. 9.5 amperes multiplied by 4.2 ohms is equivalent to 39.9 volts. So our answer is, you would need 39.5 volts to meet the requirements. Now how about this problem? We've got 8.2 milliamps flowing through a resistance of 1.4 kilo ohms. Now, this M over here, this tiny m, that's milli, by the way. And this K is kilo. You've already seen those numbers before, but just as a review. So, calculate the voltage needed for the current to pass. So what's our given? So, our given is a current is 8.2 milliamperes, and our resistance is 1.44 kilo ohms. But the thing is, in order to use our formula, we have to convert these units into amperes and ohms. Because remember, our given is in milliamps, and this one is in kilo ohms. We have to convert those to just amps and just ohms. So how do we convert that? So we got to convert 8.2 milliamperes into normal amperes. So just turn this into a normal fraction. Remember, any number divided by 1 is just itself, so really there's no change here. But we got to change the unit. So we got to multiply it with another fraction that changes the unit so that they cancel. So amperes or milliamperes is on top, right? So when the fraction that we multiply it with, milliamperes has to be on the bottom. And for every 1 milliampere, how many amperes are there? So remember, milli is just like 3 zeros behind the decimal. So it's just 10 to the power of negative 3. So as you can see, the units here cancel, right? The milliamps on top here and the milliamps below here, they cancel. Put that in your calculator and you'll end up with 8.2 times 10 to the power of negative 3 amperes. Same thing also for resistance. Resistance, and we turn the kilo ohms into regular ohms. I really shouldn't have to explain this because this is something we're supposed to or we're expected to master by now. So please practice on that if you haven't. So now that we have the values of our ohms and amperes ready, we can now plug it into the formula. V is equivalent to I times R. So 8.2 times 10 to the power of negative 3 amperes multiplied by 1.44 times 10 to the power of 3 ohms is equivalent to, or is approximately to, 11.81 volts. Therefore, our answer is the voltage needed is around 11.81 volts. Next problem. You're working with a high-power electric generator. The generator supplies electricity to a large industrial machine with a resistance of 1 times 10 to the power of 2 ohms. The current flowing through the machine is 48 amperes. You need to determine the voltage output of the generator to ensure that it operates safely. So, what's our given? We have 1 times 10 to the power of 2 ohms. That's just 1 followed by 2 zeros. So 1 followed by 2 zeros is 100. So we've got 100 ohms. And we're also told that the current in the machine is 48 amperes. So what is the voltage needed for all of those things to happen? So our formula, let me just get rid of the problem over here because it's really taking up too much space. But anyway, our formula is 48 amperes multiplied by 100 ohms. We'll end up with 4,800 volts, or 4.8 times 10 to the power of 3 volts, or 4.8 kilovolts. Remember, kilo is 1,000, so it's got 3 zeros. I just assume that this is like a 1,000, and 1,000 has 3 zeros, right? So it's the same thing here, because 4.8 followed by 3 zeros is just 4.8 kilo ohms, and also because this is raised to the power of 3. So our answer is, the voltage supplied by the generator should be 4.8 kilovolts. But really, you could also just write 4,800 volts, or you could just write 4.8 times 10 to the power of 3 volts. It's really up to your preference or what the instructions ask for. This time, let's solve for resistance. What amount of resistance is required for 6.1 times 10 to the power of 2 amperes to flow from a source of 44.53 kilovolts? What's our given? We are told that our current, amperes over here, is 6.1 times 10 to the power of 2 amperes. Now 10 to the power of 2, that's just 2 zeros moving to the right. So move the decimal place twice to the right. And that's just 610 amperes. And our voltage is 44.53 kilovolts. This time though, what's our solution? We're solving for resistance, right? And we're being given voltage and current. So which formula here solves for resistance? It's this one over here, right? So our formula is R is equivalent to voltage over current. So 44.53 times 10 to the power of 3 volts, again, is to the power of 3 because it's kilo, divided by 610 amperes. Put that in your calculator and you'll end up with a value of 73 ohms. Therefore, our answer is the amount of resistance required is 73 ohms. Next problem. Despite the massive voltage of 5.63 kilovolts, your ammeter is a tool, by the way, that's used to read current. Your ammeter only reads 11.2 amperes. What could be the resistance of said device? So what's our given? Our given is, for our voltage, it's 5.63 kilovolts, and our current is 11.2 amperes. So what's our solution? Again, R is equivalent to voltage divided by current. So 5.63 times 10 to the power of 3 volts divided by 11.3 amperes. Actually, yeah, this is all supposed to be 11.3. Sorry for the typo there. It's supposed to be 3, not a 2. Anyway, put that in your calculator and you end up with a value that is approximately 498.23 ohms. Therefore, our answer is the resistance of your device is approximately 498.23 ohms. Now for the final problem, your LED lights are powered by 6-volt battery. The current flowing through them is 0.25 amperes. What is the resistance of your lights? Again, with the given, our voltage is 6 volts, our current is 0.25 amperes. And our solution is 6 volts divided by 0.25 amperes is equivalent to 24 ohms. Therefore, our answer is the resistance of your lights is worth 24 ohms. So, that's pretty much it for when it comes to the math of Ohm's law. It's pretty easy if you ask me. I mean, compared to everything else we've been through, this is relatively easy. But obviously, in our exam, it's not going to be just this. There are still more topics for us to solve and stuff like that. But please do be familiarized with this, especially because later on, we're definitely going to solve problems that are, yes, it's about Ohm's law, but the thing is, we're going to have to use different formulas that are used to solve for voltage and amperes and resistance. And we'll meet those formulas later on. But as long as you remember the very core bare bone basics of Ohm's law, you should be fine. So, thank you.